Hello, good afternoon, students. I hope I am like let's do a technical poll. Am I audible? Please answer in this technical poll if you guys can hear me. Okay, I'm assuming that you guys can hear me. Okay, so in the previous classes, as far as I remember, I took your classes. We learned about tangents, yeah, different type of equations of tangents. So we derived what should be the equation of a tangent and we derived it in different format. So for today, what we will be learning is we studied about tangents. Now we will be studying normal. What is a normal? First of all, let's clear this out. Consider this as a tangent. Then if you draw a perpendicular line to this tangent. So if this is a tangent, this will become our normal. Okay. And then we will be studying about director circle. And then we'll be solving few questions which were asked previous year. Okay. So the equation of normal at point P x1 comma y1 on the ellipse is given by this thing. Okay. So this is our ellipse. This is the equation of normal. Now the question is, how do we come to derive this thing? Okay. So let's see. Whenever see the equation of ellipse x square by a square plus y square by b square is equals to 1. Okay, so now if I have to find what this statement is saying, the equation of normal at point p x1 comma y1. So this point p x1 comma y1 is on the ellipse. So that is one important point to note. When it is on the ellipse, we can find the slope at that point of tangent. Okay, so how do we find the slope of tangent at p x1 comma y1. Okay, how do we do this? We differentiate this, so it becomes 2x upon a square plus 2y dy by dx, this upon b square is equals to 0, right? From this we can get dy by dx is equals to, what will be our dy by dx? It will be minus b square x upon a square y. So this is the slope of tangent. Okay, so this is the slope of tangent. Now if I know the point P where I have to find the equation of normal, and if I know the slope of normal, then deriving the equation will become easier. So if I know the slope of tangent, which is dy by dx here, so dy by dx is slope of tangent. What will be the slope of normal? What will be the slope of normal? Yeah, at one point, at a point, if you draw tangent and then you draw perpendicular line also, then the product of these two slopes, consider this is m1 and this is m2, then m1 m2 is given by -1, right? So the slope of normal will become minus dx upon dy, correct? So minus dx by, we know dy by dx. We have to find minus dx by dy. So which will become a square y upon b square x. Okay. So you can check this out here. Correct. Now, now to derive the equation, now to derive this thing, see, we have an ellipse. We are drawing a tangent at point x1. This point is given by x1 comma y1, and you have to find the equation of normal. So equation of normal. We already know the slope. We already know the slope a square y by b square x. So now slope point form of a line. What how it is given? It is given by y minus y1 is equals to m into x minus x1, right? This normal will be passing through the point x1 comma y1. So I will write this as y minus y1 equals to, what is m? This m is for normal, which we have to write. So for normal, we already found out the slope will be a square y. So this y will be replaced by y1, and this b square x will become b square x1, since we are finding the slope at point x1 comma y1. Now I will write this x minus x1. So after simplifying this, I will get b square x1 into y minus b square x1 y1 equals to a square y1 into x minus a square y1 x1. Correct? Now I'll shift this term on the left, and I'll bring this term on the right. So it will become a square minus b square into y1 equals to, this becomes a square y1x minus b square x1 y. Correct? Now we will divide both sides by x1 y1. Okay, so after I divide both sides by x1 y1, this side I am writing first. This will become a square x upon x1, because this y1 will be cancelled out by the y1 which comes in the denominator after this step, and minus b square y upon y1. This will be equals to a square minus b square. This x1 y1 will be whole taken by this x1 y1. Now you can see here that the equation of normal, which was written here, has been defined. Correct? So this is how you find or derive the equation of normal in slope point form. And this equation of normal is derived at the point P x1 y1, which is on the ellipse. So this point is important. Okay. Moving further, equation of normal at point P a cos theta comma b sin theta. So guys, we already know that the parametric parametric representation of a point P on ellipse is given by a cos theta comma b sin theta. Correct? So this is the parametric form of point P. Any point that lies on, this is any point that lies on ellipse. Correct? Now we have already derived for point x1 comma y1. We have already derived the equation for point x1 comma y1, which was given by a square x by x1 minus b square y by y1 equals to a square minus b square. Now this x1 is simply being replaced by a cos theta, and this y1 is simply being replaced by b sin theta. So let's use these 2 points here. Okay, this x1 will be replaced and this y1 will be replaced. X1 will be replaced by a cos theta and y1 will be replaced by p sin theta. So what will the equation become? A square x upon a cos theta b square y upon b sin theta equals to a square minus b square. Correct? Now if you cancel this a, cancel this as well. So what remains is ax upon cos theta minus by upon sin theta equals to a square minus b square. Are you guys getting this? So now this ax by cos theta, so that cos theta in the denominator can be taken as sec theta in the numerator. So what I can write here is ax into sec theta minus by, and that sin theta in the denominator can be written as cosec theta equals to a square minus b square. So you guys can see here, this is how the equation of a normal in parametric form is defined. Correct? Are you guys able to understand this? All right. Let's move ahead and see. Now, now the equation of the normal with slope m to the ellipse. Okay. So in this thing, the equation of, see, here we had defined for the tangent when the slope was m. Now this equation is defined for this normal where the slope of this normal is given by m. So what will be the slope of this tangent? It will become minus 1 by m, right? So this will become minus 1 by m, correct? Yeah. So now to find the slope of to find the equation of normal in slope form where the slope of the normal is given as m, what we will do is, we remember there was some condition, over this tangent. It was given by c square equals to a square m square plus b square, something like this was given, correct? And the equation of the tangent was y equals to mx plus c in that scenario. Now the equation of the tangent will become what? See, this is slope m for the tangent in previous case. So you guys should remember that now that condition has changed to something like this. So that c is equals to m square into c square is equals to m square into a square minus b square का whole square upon a square plus b square m square. So this is the condition when this line will be the normal to the ellipse. Okay, and the slope of this normal will be m. So So these are the three types which you have to remember. One is slope point form, the other is in parametric form, and the last one when the slope of the normal is given as m. Okay. Now, to find the foot of the perpendicular of normal with slope m is the same as point of contact of the tangent with slope minus 1 by m. So, do you guys remember what was the point of contact? Yeah, sorry for that. So, the point of contact was given by plus minus a square m upon under root a square plus b square. And p square upon a square m square plus b square under root. So what this statement is saying is that thus that the point of contact, that this point of contact of the tangent with ellipse, this slope is m, is same. Now if you want to find out the point of contact of this normal with the ellipse, so this normal has a slope m. Okay, now if the slope of the tangent was taken as 1 by m and used in this point of contact formula, we will get the point of contact of this normal. Okay, to find the point of contact of normal, just replace that slope by minus 1 by m in the point of contact of tangent. So you get the point of contact of normal. Okay, now the locus of intersection of perpendicular tangents. So we have to find the locus of intersection of perpendicular tangents in case of an ellipse. So like this, we did for circle also. Yeah. So for circle, do you guys remember what was the scenario for circle? So for a circle, we derived something like this, and this was perpendicular, and this was the tangents also came out to be a circle, right? So the information that has been given here is that the locus of this perpendicular tangent falls on a circle, falls on a falls on a circle, and this circle is called as director circle. This circle is called as director circle and the equation of this circle for an ellipse x square by a square plus y square by b square equals to 1. For this ellipse, the equation of the director circle is given by x square plus y square equals to a square plus b square. So this is the equation. From this, what we can conclude is what is the radius of the circle? See, we already know that this length is a and this length is b, right? So applying Pythagoras theorem in this triangle, you can say that this length is under root of a square plus b square, right? So now I can also write this equation as x square plus y square equals to under root of a square plus b squares whole square, right? Now what is the this becomes radius, right? So x square plus y square equals to r square is the general form of circle whose center is at origin. So what is the radius? Radius is given by root of a square plus b square. So that root of a square plus b square is the length connecting the ends of major axis and minor axis of the ellipse. Correct? You can see here that length is the ends connecting ends of major axis and minor axis which has been connected. Yeah. So you guys should remember this point. Okay. So now let's move on to solving some question. So this is the question. Come on, you guys should also try. So here, let's see. Here the equation of tangent is given by 3x plus 4y equals to 12 root 2. So let's not get confused and just try to frame this thing into the format y equals to mx plus c. Since if you do it like this, you can get the value of m, and hence if you know, you can get the value of m and c, and from this you can calculate a and b somehow. So that is what this question is all about. So if I want to change this into y equals to mx plus c form, what I'll do is 4y equals to minus 3x plus 12 root 2. Now I'll divide throughout by 4. So y will become minus 3 upon 4 into x plus 3 root 2. So from here, by comparing this to y equals to mx plus c, you can say that value of m is minus 3 by 4 and value of c is 3 root 2. So using this, so for this line to be a tangent, we already know that c square should be equals to a square m square plus b square, right? So we already know the value of b square. B square is given as 9. You can see here in this equation, the equation of ellipse is given by x square by a square plus y square by 9 equals to 1. So this is our b square. So we will be using that b square over here. So c square, what will be the value of c square? C is 3 root 2. So c square will become 18, right? So this we will write as 18 equals to a square m square. M is minus 3 by 4. M square will be 9 by 16 plus this b square will be 9. So we can see that this 9 comes out to be common. 9 9, this becomes 2. So this will become ultimately 2 equals to a square by 16 plus 1. So what will be the value of this thing? This will become a square will become 31, 32 minus 16 upon 16, which will be 16. So value of a will be 4. So what has been asked? Then the distance between the foci of the ellipse. We know that the foci of this ellipse is given by minus AE comma 0 and AE comma 0. So this distance between the foci can be written as 2AE. Now we already know the value of A. We need to find the value of E. So we know that E square is given by 1 minus B square by A square. 1 minus B square is 9 and A square is 16. So this becomes 7 by 16. So E comes out to be under root 7 upon 4. Hence 2AE will be equals to 2 into A. Value of A is 4 and under root 7 by 4. So this comes out to be 2 root 7. Hence the answer to this question is 2 root 7. I hope it is clear to all of you guys. Let's move ahead. Now, let's check out what this question is saying. The normal at point P on the ellipse meets x-axis at Q. If the midpoint of the line segment PQ, if M is the midpoint of the line segment PQ, then the locus of M intersects the lattice rectum of the given ellipse at the point. So it is given as something like this. So this is the equation of the ellipse x square by 16 plus y square by 4 equals to 1. So this is the ellipse that has been given to us. It is saying the normal at a point P on the ellipse meet x-axis at Q. So consider any point P. So normal at this point, normal, you draw the normal at this point. This meets here at Q. If M is the midpoint of the line segment PQ, if M is the midpoint of the line segment PQ, so this is P, this is Q, so this is M. Then the locus of the point M intersect the lattice rectum at what given point. So we have to first find the locus of this point, and then wherever this will intersect the lattice rectum. So we have to find that intersection point. So how will we approach this question? See, the normal at any point P we just did at any point P a cos theta plus b, sorry, a cos theta comma b sin theta is given by normal. Normal can be written as ax sec theta minus by cosec theta equals to a square minus b square. So a, what is the value of a? We can see here a square is 16. A square is 16, which makes a equals to 4. B square is b equals to 2. So we'll write 4x into sec theta minus 2y into cosec theta. A square minus b square, 16 minus 4 is 12. So this will be further reduced to 2x sec theta minus y cosec theta equals to 6. So we got the equation of normal. So this equation of normal meets the x-axis at some point. So this meeting at x-axis will make the y-coordinate as 0. So x-axis will get the point where it meets the x-axis. So when you do the y-coordinate 0, you get 2x. You get 2x sec theta equals to 6. So you get x equals to 3 cos theta. So this point Q can be written as 3 cos theta, comma 0. Yeah, and P is given by a cos theta, which is 4 cos theta, comma b sin theta, which is 2 sin theta. Now the midpoint of this PQ, midpoint M can be written as, let's say M is h comma k. So 2h will be equals to 7 cos theta and 2i will be equals to 2 sin theta, right? So we can write here as 2h upon 7 equals 2h upon 7 whole square, which is cos square theta, plus 2y upon 2 whole square, which is sin square theta, is equals to 1. So we get here the equation will be 4x square upon 49 plus y square equals to 1. Now what is the equation of this lattice rectum? Equation of this lattice rectum is x equals to AE. So equation of the lattice rectum of this ellipse can be written as x equals to plus minus 2 root 3, right? So we substitute this point here and we substitute x equals to 2 root 3 and then we get y equals to plus minus 1 by 7. Hence, the coordinates of the point that we are supposed to find is given by plus minus 2 root 3, comma, plus minus 1 by 7. So I hope this question was clear. This question is easy to understand once you have found out the equation of normal and this h comma k point. Now, let's do this question. Here, what it is saying is an ellipse has OB as semi-minor axis. First of all, let us draw an ellipse for our reference. Here, it is saying that an ellipse has OB as semi-minor axis. So this is origin. So OB, let's say this y minor axis lies on OB. So this is our B, and F and F dash are its foci. So this is, let's say F, this is F dash. So the coordinate of F is minus AE comma 0, F dash is AE comma 0. And this point here will be B comma, sorry, 0 comma B, right? This will be, this will be 0 comma B. Okay. So what this question is saying is FB F dash is a right angle. FB F dash, this is a right angle. Now we have to find the eccentricity of the ellipse. So what is this distance? These two distances are same, right? We know that distance between the focus is 2AE. Now, since this is a right angle, we can apply Pythagoras theorem. This square plus this square will give you 2AE ka square. What is the distance between these points? This is A square E square plus B square under root plus again from this point also the distance is same, which will come out to be A square E square plus B square under root equals to, now this distance. This distance is 2E, so its square will be 4A square E square. Now this becomes 2 times under root of A square E square plus B square equals to 4A square E square. You cancel this by 2. Now if you square both the sides, sorry, this whole square y2 minus y1 whole square. Yeah, so here we get a square e square plus b square equals to 2a 2a square e square. So here we get a square e square equals to b square. Now we get b square equals e square equals to b square by a square, which is also equals to. Now we also know that e square is also equals to 1 minus b square by a square. So we can write this b square by a square as e square. So I'll get e square equals to 1 minus e square, which will give me 2 e square equals to 1. So value of e will be 1 by root 2. So the answer is option A. Yes. Let's do one last question. Find the equation of the ellipse whose axes are the axis of coordinates and which passes through the point minus 3 comma 1 and has the eccentricity root over 2 by 5. So E is given by root 2 root over 2 by 5. So from this we can say E square will be equals to 2 upon 5. So from this we can say 1 minus b square by a square equals to 2 by 5. So b square by a square will become 1 minus 2 by 5, which is 3 by 5. Now we know that b square by a square is has become 3 by 5. Let's say b square equals to 3k and a square equals to 5k. So this thing will satisfy this. Then the equation of the ellipse under this condition will become x square upon a square plus y square upon b square is equals to 1. So x square by a square will become x square upon a square is 5k plus y square upon b square is 3k. This becomes 1. Now this ellipse is passing through the point minus 3 comma 1. So that means minus 3 comma 1 will satisfy. So substituting minus 3 comma 1 in this equation, we will get 9 upon 5k plus 1 upon 3k equals to 1. So from this we can calculate the value of k. It comes out to be 32 upon 15. So now we have got the value of k, which is 32 by 15. Therefore the equation of the ellipse will be x square upon 5 into 32 by 15 plus y square upon 3 into 32 by 15 equals to 1. This 5 ones are, this becomes 3, this 3 ones are, this becomes 5. So the equation of the ellipse will be 3x square upon 32 plus 5y square upon 32 equals to. So I hope you guys understood this question. So to summarize, what things we did is we studied equation of normal in three forms. First was slope point, second was parametric, and third was when slope of the normal is given as m. Correct? And then we studied about director circle, which is the locus perpendicular tangents. After that, we did few previous. Prabhat sir is joining in 2 to 3 minutes. Questions. So I hope this class was understood by everyone. Thank you so much. Have a good day, guys.